Hello friends, today we are going to discuss about WhatsApp, how WhatsApp is working behind the scene. And yes, it is a very well-known interview problem as well. So before jumping to the actual solution, let's discuss our requirements and NFRs. Here we'll assume that we need to build a WhatsApp MVP4, messaging from user A to B, message status like delivered or read, user status with last seen info, how to save media, messages like photo, video, audio, encryption of the message, calling audio and video, and group messaging. Let's move to the architecture. So this is a very basic architecture of WhatsApp in which message initiated from Tom, message is received by messaging server via load balancer. It is for Jerry, hence server send this message data to Jerry. Happy ending for the movie. This is how a happy case scenario completed. To have this messaging flow from user A to user B, the connections usually we prefer WebSocket or full duplex connections where client can send message to server and server can send message to client. Also there is a database where we persist the data. What is the use of this database and how it will be in act in this architecture? We'll take it further. But as I said, nothing is easy and happy as it looks like. So WhatsApp architecture is not similar to this. So let's find out the solution of these concerns like if user A's internet is off, then what will happen to message A? Scenario B, if user sent a data successfully and it received to messaging server, but user B's internet is off. So how all these things will be catered in our architecture? Let's move to the solution for these concerns and the flow of packet for a particular message. Cool. So let's digest the diagram first. So we have a messaging server contains processes and queues dedicated to the online users. A table contains mapping of users and its dedicated processes plus queue IDs. A flow of message A which Tom wants to send to Jerry. Let's walk through the flow and understand the overall schema. Tom typed a message A. Tom device is connected to messaging server and allocated process ID PA. We can see this in this table as well. PA received the message and checked receiver's information at the message. So this message is for Jerry. So PA checks the responsible queue for Jerry in this table. So as we can see, QB is allocated for Jerry. Found QB for the same, PA put message in QB. Now the process which is dedicated for Jerry, PB as a regular cycle consumes this message A and send it to Jerry's device, where Jerry read the message. As and when Jerry read the message, the device of Jerry sends a signal to Tom's device. So but that message again go via process B. Process B took that message, the signal read signal from Jerry's device, then that read signal saves in QA. PA read that read signal as usual process and send it to Tom's device. As and when Tom's device received that signal, we'll see the blue tick. So via this signals 0, 1, 2, 3, 4, the different stages of this message, what we are trying to explain here is 0 message is sent by initiator, 1 single tick because messaging server acknowledged the message, 2 and 3 are the internal processing, so it will be the same stage for the message, 4 double tick as Jerry's device received the message and acknowledged it. As and when Jerry will read this message, the read signal will be initiated, which I already explained. But what if Jerry is not online? In this case, what will happen? So, there will not be PB or QB aligned with Jerry. When PA find the process responsible for Jerry, it didn't find anything. So, it saves the message into a database. That database is unsent messages database. How that table schema looks like. This kind of a schema for the unsent messages where receiver is Jerry and message is messenger. So this message is not sent to Jerry yet. So for all such messages, PA will put it into database, and whenever Jerry device will come online, the process will be allocated to Jerry. Let's assume it is PB. So apart from what we discussed, the job of a process, whenever a new process allocate to any device, process will check for all unsent messages for that particular user, which is Jerry in this case. If the message is present in the unsent messages table, all the messages will be sent to Jerry. Also, at a given certain time duration, the device sent the online signal to the process, which it stored into a database from which we can get the information of last seen. So this is how we are showing the different stages of the message and user last seen info. Cool. So in this video so far, we have covered our first three requirements: messaging from user A to B, message status like delivered, read, not read, only received by the server, user status with last seen information. All three are covered. Stay tuned, friends. I'll cover the remaining four in my next video. I hope you liked the content. Happy to take any feedback. Do like, share, and subscribe.